universal solvent. A number of species in solid or soluble forms are found in water from different sources. Most important concern of humankind is about the presence of toxic metals in water. For addressing this problem, it is essential that we should have knowledge about the presence of different forms of toxic heavy metals in water from different sources. Here, presence of different forms of some toxic heavy metals has been discussed. Let me take first lead. Lead in water samples is generally found as elemental lead, lead oxides, lead hydroxides, and lead oxoanion complexes. Low solubility compounds of lead are formed by complexation with anions, carbonate, chloride, sulfate, phosphate, organic ligands. Other examples are humic, fulvic, and amino acids. Now next element is chromium. Chromium does not occur in nature in elemental form. It is found in the form of compounds. It is found mostly in +6 oxidation state. This is found in +3 oxidation also, depending on pH and redox conditions. Chromium in +6 oxidation state exists in shallow aquifers where aerobic conditions are available. Major chromium +6 species include chromate and dichromate. Chromate 3 plus is dominant form of chromium at lower pH. Cr3 plus forms soluble complexes with ammonia, hydroxide, chloride, sulfate, and organic ligands. Chromium 6 most forms toxic form of chromium and is also more mobile. Now next element is arsenic. In aerobic environment, As+5 is dominant usually in form of arsenate in various protonation states. Arsenate and other anionic forms behave as chelates and can precipitate when metal cations are present in water. Next element is cadmium. It occurs naturally as CDS, CdCO3, cadmium element. The forms of cadmium depends on solution and treatment of waste before disposal. The hydroxide and carbonate of Cd solids dominate at high pH, whereas aqueous cadmium sulfate species are the dominant forms of cadmium at lower pH. Now next element is mercury. After release to the environment, mercury exists in Hg2 plus state and Hg+1 state as mercuric and mercurous elemental or alkylated form, that is methyl mercury or ethyl mercury. The redox potential and pH of the system determine the stable forms of mercury that will be present. Mercuric and mercurous are more stable under oxidizing conditions. When mildly reducing conditions exist, organic or inorganic mercury, may be reduced to elemental mercury, which may then be converted to alkylated form by biotic or aerobatic process. Friends, this information given to you is of most important for research work, because if someone is doing research work in solution chemistry, he would get this information in advanced literature. Thank you very much.